and then we will start discussion. Mic check. Hello. Yeah. So today we are discussing about automation in KiCAD using one special plugin called KiKit. Okay. I think I have a presentation also. So today it's not just a theory; it will be very useful. So I think last time you have sent me one project, right? Related to ESP32 and one project. So using whatever the concept that we are learning today, how to do the automation, I will be telling you. Okay, it will be very useful. Yeah. So let me just open the PowerPoint. So before I begin the session, can you just confirm me if you are able to see my screen?
Yes.
Yeah. Wait a second. Let me also reshare with audio.
Hmm?
Yeah. So I request you. So kindly please in the today's session, I request you to pay
Hmm.
attention. So whatever we are learning today would be very very useful. So that's why I just started this session. So I'm just beginning the presentation. I hope you are able to see my screen, right? So we are having one vision to empower 1 million students by 2040.
Okay, what's it apply?
Yeah, I hope you are able to see my screen, right?
Clearly.
Yeah. So today we are discussing about it's a special class on how to use this KiKit and to do automation in KiCAD. Okay, so basically it's an automation tool. So there are so many advantages by using KiKit. We will discuss in detail in the upcoming session. So today I will give you a basic overview. See, basically you are having only one single PCB like this, right? Yeah. So now if you want to see at the time of placing
Yes.
an order, individually you cannot place these many PCBs order. So instead of what we are doing is like we will be converting the single PCB into a single PCB file which is having many PCBs, an array of PCBs. So this particular conversion of the one single PCB into an array of multiple PCBs is called as panelization. Is that clear? Now you understood the term panelization?
Yes.
Yeah. So actually KiCad supports, see, in ECEDA there is no option to use plugins, but whereas in case of KiCad, there's an option to use external plugins also. Okay, by default some plugins will be there, and also we can use some external plugins also. So each and every plugin will be having some specific functionality. For example, let's take KiKit. So KiKit is also one kind of plugin. So it is used for automation of panelization of PCBs. A single PCB that you are designing, that can be converted into an array of PCBs. Okay, again there are so many parameters. So everything cannot be covered in a single session, but we will discuss in 2 or 3 sessions. Okay. Yeah. So, but before going to discuss about how to use KiKit and automation tools, first we need to understand some basic terminology. I will don't go that much of very detail in theory because I will directly jump into demonstration. But at least we need to have a little bit understanding about what is panelization, what are different techniques, so what are different methods available. Okay. So PCB panelization is a technique of manufacturing a collection of PCBs together on a single layer panel. See, if you just check this image, so this is actually a single PCB and this is also a single PCB file. Okay, but inside the single PCB file we are having multiple PCBs stacked together. Okay, it's like an array of PCBs. So that's what mentioned here.
What's
It
the
is a
same?
it is a technique of manufacturing a collection of PCBs together on a single layer panel. Is that clear? Hello.
Hello? Yes.
Yeah, I hope you can hear me, right?
I can hear you clearly.
Yeah. So why we need to do this? Because it makes our thing easy, assembly, everything easy. Because individually, if you purchase many PCBs, that is not a efficient way. So that's why we need to place a panel. Whenever you are placing any PCBs, see this is actually used to the main purpose is to optimize and increase efficiency. Okay, and apart from this, for PCBs smaller than 50 into 50 panelization is highly recommended. Okay, it doesn't mean that PCB is greater than 50 into 50 cannot use panelization technique, but for smaller PCBs usually we recommend panelization. Okay, now and I hope you understood what is meaning by panelization. So basically it is nothing but
Yes.
manufacturing a collection of PCBs together on a single layer panel. So now here comes another term, depanelization. Okay, so one is panelization and another one is depanelization. So depanelization is exactly opposite of panelization. So in depanelization, it is the separation of individual circuit boards from the PCB panel or array. See, in panelization, what we are doing, we are designing multiple PCBs on a single PCB layout file. But here in the depanelization, we are separating those PCBs. Okay, so this is the depanelization. So again in depanelization there are many methods. I just listed two methods only. Okay, in the upcoming session we will discuss what are the other methods also. Just give me a second, let me just confirm if the stream is also, yeah. So there here I just listed two methods. One is stamp hole method and another one is V cut method. Okay, one is stamp hole method and another one is V cut method. These two are common depanelization technologies. So one we have stamp hole method and another one we have V cut or V scoring method. Okay, so two common methods depanelization technologies I have listed here. So now let's discuss and let's analyze its advantages and disadvantages and compare it with the V scoring depanelization method. So stamp hole method we are comparing it with V cut or V scoring depanelization method. See, this is the depanelization. Okay, this is a paneled PCB. Okay, now we need to depanel. That means we need to separate these PCBs from that panel. So stamp hole is a method of drilling small holes on the predetermined dividing line of the circuit board so that the board remains connected during the production process and finally separated by simple breaking or cutting with a separation machine. This method is similar to, okay, yeah. So whatever I just underline here, that is important. So stamp hole is a method of drilling small holes. Basically, every PCB, between every PCB, see here also you can see some holes, right? Few holes. Can you see that?
Yes.
Yeah. So those are nothing but stamp holes. So stamp hole, like basically we'll be having one divide line. That line is predetermined. Okay. So basically we'll be having a predetermined line. Again, there are so many things are there, like how you should align the dividing line. There are so many things. But as of now, what you need to understand is like there is some predetermined line, dividing line, and on the top of that line you will be drilling some holes. So basically it enables you to separate the PCB easily. Okay, basically at the time of production, uh, you know it will be the manufacturer is designing all the PCBs at a time. Okay, like as a layout panel. So but at the time after, once the production process is over, finally they are separated simply by breaking, or else they will be using some separation machines. So by that they will be depanelizing the PCBs. So this is how PCBs are actually manufactured. Even though if you order a single PCB for multiple times, usually there would be a separate team. They will convert this single PCB into panel PCBs, and then they will manufacture, and they will using the separate, after production is over, they will use separating machines to depanelize these PCBs. Okay, so yeah, this is about stamp hole. Yeah, there are some design suggestions. Okay, we will discuss about these design suggestions. So some measurements, all these parameters in detail, advantages of stamp hole, and so again in depanelizing, there are different methods. Okay, I just listed only two common methods: stamp hole method, V scoring method. So apart from stamp hole and V scoring method, there are other methods also, like tab routing, laser cutting. I hope you know about laser cutting, right?
Yes.
Yeah, so basically with the help of a laser we can also separate these PCBs, panel of PCBs. So like this there are different manual break, laser cutting, tab routing, V scoring, stamp hole. Yeah, so we will discuss about these methods in detail in separate PPTs in the upcoming sessions. So now we are discussing about V scoring method. Okay, so first I will show you one thing. So first I will be showing you one thing, how to implement, how to generate. First I will show you how to install KiKit on your KiCAD. Okay. So for that, what you need to do is like, first you need to just navigate to KiCAD. So I'm just opening KiCAD, KiCAD 10.0. See, now what I will be doing is, I'm just opening one project. Okay, now whatever I'm just opening is the same project that you sent to me. Okay, to analyze. So I'm opening the PCB file. See, is this the same project that you sent me?
Yes.
Yeah. Let me just also once check the 3D view. See, now you are having a single PCB and you need to, with the help of KiKit, you need to panelize it. Okay. Yeah. As I can see, this is a single PCB, right?
Yes.
Yeah. You have added your logo, made in Nigeria, designed, powered and designed by Robocraft Africa, right? Robocraft Africa. Good. Nice logo. So now we need to do, see, you cannot directly place a single PCB order. Okay, it is not efficient for the manufacturer also. Okay, for production also it is not a effective way. So what you need to do, you need to panelize this PCB. So to do that, first what you need to do is like, I'm just going to the home screen. Okay, here at the end you can find one option, plugin and content manager. Okay, click on plugin and content manager. So once you just click on plugin and content manager, it will show you another dialog. Okay. See here,
Yes.
I will show you. See, there are so many automation tools. Here you can find so many automation tools. So out of them, we will discuss one tool. In each and every session, we will discuss about some tools, automation tools. So now here there is a search bar. Here you just search for KiKit. Okay, just search for KiKit. Then you will find one such kind of tool. Yeah, this is the KiKit. So already you can see it is already installed on my device. Okay, if in case it is not, if in case it is showing install option, just click on install. And once you click on install option, it doesn't mean that automatical, when no sooner you click the install, automatical installation won't begin. So again here you need to click on apply pending changes. Unless you click on apply pending changes, whatever the things that you, whatever the plugins that you're trying to install from the official repository, or any plugins, they won't get installed. You need to apply the changes. First you need to click on install. Okay, whatever the plugins that you want to install, just click on install for all the plugins and then click on apply pending changes. If in case you want to cancel, you want to terminate the installation, click on discard pending changes. Okay, then installation won't begin. So well, just click on install option and then click on apply changes. So apart from this, again, see here, just search for KiCAD command prompt. So I just want to ask you, have you ever used this KiCAD command prompt ever before?
Yes, you have taught us before.
Okay, like what kind of operations have you performed from here?
I can write my Python code using it. I can
No, no,
automate a
no.
lot of things
That
on it.
command prompt is different. That command prompt is different. Like the regular command prompt is different from the KiCAD command prompt that we are discussing.
Okay.
Yeah. So here they see this KiCAD command prompt. You know, will be installed on your system whenever you install that KiCAD software. Okay, it is not
Yes.
by default, it won't come, but the regular command prompt or else PowerShell, they come by default. Okay, system powered by system. So these are like from KiCAD. So I will shall okay, before I begin how to install KiKit, so let me start by explaining you few some basic commands which we use in KiCAD command prompt. Okay, so basically we call this as KiCAD CLI. We usually call this as KiCAD hyphen CLI. So what do you mean by CLI? Any idea?
Command line interface.
Yeah, perfect. Command line interface. So there are so many command line interface tool. For example, if you want to check what is the version of your CLI, just type version KiCAD hyphen CLI hyphen hyphen version. It will return the version. Okay. Similarly, here you can, for example, if you want to export the schematics, okay, there are two ways to export the schematics, through graphical method, and one another one is to command line interface. Okay, you can export any schematic into PDF, SVG, PNG, or any other file format. Okay, so for example, mm, so this is the schematic file, right? Now if I just want to export this into some PDF, so first let me just navigate where is that particular file is located. Okay, so now what I'll be doing is I'm just trying to locate where that particular file is present in my uh, okay, in file explorer. Yeah, so where is the schematic file? This is the project file. Mhm. Yeah, this is the schematic file. So now what I'll be doing is I'm just clicking on copy as path. Okay, again come back to command line interface. Okay, the first thing what you need to type is KiCAD hyphen CLI. Okay, which means command line interface. And then, so what there are multiple tools. Okay, maybe in the next session I will explain you in detail about all the commands which are present in KiCAD command line interface. So KiCAD hyphen CLI space SCH means schematic. Okay, then I'm just typing export. So I want to export this into PDF. If you want to export this into image format, you can type SVG, or else you may also use PNG also. Okay, whatever the file format you want, you can export into that particular file format. For example, I want to export into PDF. So here you need to provide the you know the path of the
The
schematic
path.
file. Okay, yeah, then you can hit enter. See, plotted to epaper esp32.pdf. So basically this is a, having the file extension. The input file that you have provided is having the file extension KiCAD underscore sch schematic file. Now if you just observe the file extension, now it is showing .pdf. Now let's see how is that PDF looks like. Let's just verify. So also you can provide one more parameter also, that is the destination location. Okay, destination location where you want that PDF to be stored. That location also you can specify. For example, hyphen o means output, where you want that output PDF which is generated to be stored. Okay, so for that I'm pasting the same folder. Okay, e-paper ESP32. Okay, or else we will do one thing. First we will navigate to that particular folder. It should work actually. Let me see again. So e-paper ESP32 downloads. Let me check the file permission first. Maybe if any permission is restricting.
Security.
See here you can find only read only. So I'm just changing the permission. Earlier it was only just read only. Click on OK. Let me give one more try. Again failed to create. I can export PDF.
But
That's
it's
fine.
clear to me.
Okay, so I'll just look into it later. So right now I'm just passing this command plotted to ePaper ESP32.pdf. So now I'm just going to KiCAD folder. So here you can find the path. Okay, so star documents KiCAD 10.0. Is it downloads or documents? Yeah, downloads. Mm, documents. Yeah, documents and then KiCAD 10.0. So here you can find that PDF. ePaper ESP32. So I'm just opening that PDF in Adobe Acrobat. See, this is the schematic. Not use the graphical method, okay, graphical representation. We have used the command line interface uh, to plot the PDF. See, this is the another way. But ideally, you should know all the methods because sometimes in certain cases we may need to use the command line interface also. So it's better to know all the different, see how it plotted the PDF. In the same fashion, if you want to export it into SVG, okay, I'll show you. Just everything command is same, completely same. Just in the place of PDF, you will be typing. For example, you want PNG or SVG. So for example, I'm taking SVG. Yeah, I'm just taking SVG. Now let's see if this PDF will be exported into SVG or not. Yeah, plotted to C user KiCAD 10.0 ePaper 32.svg. You can directly copy this file path or you can directly open this file path in browser also. No need to navigate to the directory all the time. So just open your browser, paste that URL here. It will directly show you that image. See, okay, this is the way to export a PDF. Okay, plot a PDF, export it into export the schematics into SVG or PDF or PNG. So like that. So using the command line interface also we can do so many tasks, not just one or two. Last time we discussed about automation of some certain automations, how to access a PCB with the help of Python script. We discussed about scripting property in Python, isn't it? So this is the another way. So similarly you can also run DRC from here also. Okay, for example you want to run DRC, you can directly run that DRC from the command line interface also. So I'll show you how to do that. So I'm just clearing my screen to remove the unnecessary thing. So the command is KiCAD -CLI command line interface. So earlier to convert the schematic into PDF, what we used after KiCAD -CLI, we have used, first we need to type SCH. So SCH for schematic. Okay, but here uh, we have to run this DRC for PCB. Okay, PCB hyphen DRC. So we are running the design rule check for the PCB. See, PCB is the main command. This DRC is called as the subcommand. Okay, any command can have a subcommands, many subcommands. Even subcommands will have again subcommands also. Okay, so now KiCAD -CLI space PCB space DRC. Here you need to, earlier you have provided the uh, earlier you have provided the file path, the path of the file for the schematic file, right? Now here you need to provide the location of the, see, this is the SVG file that we have generated earlier with the help of command line interface. Yeah, so now here instead of the schematic file, so you need to provide, you need to copy the path of the PCB file. Okay, board, where is that board file? Yeah, here you can find KiCAD board. So I'm just right click on it, copy as path, go to command line CLI, command line interface, paste it. So KiCAD -CLI space PCB, PCB is the main command, DRC is the subcommand of the PCB command. So now where you want this output to be, like, see, whenever you just run DRC, so it will start a DRC verification, right? And it will return some yeah, just give me a second, I'm getting another call. Hello. Yeah, done. I'm good. What about you? Yes, yes. Yeah. Yeah, yeah. 14 days, for 14 days it will be free trial, no? Okay, okay, you got a mailbox. Okay, fine. Okay. No, no, actually they will limit like the number of users. So first just check, like, while buying number of mailboxes, how many number of mailboxes you got. Yeah, I think only two users are allowed, I think so. Yeah, for that actually, like, their Google will be providing. You need to change that, some you need to do some modifications to DNS record, and so that it will be like mailing services will be handled by Google. And for each and every user, like, they will be charging something, maybe 390, or maybe I just don't know exactly. Once you just check, like, the pricing, you just check. Overall 395 per month, or I think per user 395 per month, I think. Yeah. So if you want 10 users, 395, some around 300 or something like that into 10. And moreover, see, actually, Even in Jogo also we'll get one or two mailboxes for free. Maybe at least some three, or I don't know, maybe two or three they allow. But in long term, this Google Workspace is recommended. Though it's a little expensive, this is highly recommended. Yeah. So if you are unable to afford for all the things, at least to have the main domains like this, you can get something like 4 or 5 mailboxes. But the biggest thing is like we need to maintain expenses is high. Uh, I just check the information until right now I'm in class. Just 10 minutes. Yeah. Okay. Bye. Sorry. Can you hear me? Hello.
I can hear you.
Yeah. So sorry for the inconvenience. I'm just continuing. So once you are done with the DRC verification, it will return some output, right? Whether what are the different errors, what kind of error. So that thing you need to store in some file. Okay, that means you are exporting the. See, basically this command will read that you have sent me. Okay, I just perform the DRC verification for the same PCB that you send me. So for that, what it returned, 57 violations are there in your PCB. Out of that, found 138 unconnected items. Okay, finally it saved the DRC report to drc underscore output.txt. So total 57 violations, DRC violations it found. Okay, for the PCB that you sent. Now let me just check the output of that DRC. See here, a new file has been created, right? You can see that file, no? DRC output. Yeah, this is the file, DRC output.
Yes.
Now I'm just opening this file. You can open it with VS or Notepad. For simplicity, I'm opening with Notepad, or else you can use VS Code. See, DRC report for ePaper hyphen ESP32.KiCAD.PCB. So this is the timestamp at what time this DRC has been performed. So report includes errors and warnings. So total 57 DRC violations, and it is showing everything in an organized way. So where is the error? Everything. So these are the list of errors it is showing. Around 57 DRC violations it listed. Okay, so this is how you can perform DRC with the help of command line interface also. So apart from this, you can not only just store you cannot not only just storing this DRC result in a text file, you can also format the data into JSON format. Okay, for that I need to add one more attribute. I think a format JSON. I'm not sure about the command. Let me try if this works, or yeah, fortunately the command is correct. So there is one more additional attribute, format. So this using this format attribute, it actually accepts, like you can, by default if you don't specify the format, it will be considered as a plain text. If you specify format explicitly, if you mention JSON, so the data will be uh, you know converted into a JSON file format. Now let's check if JSON file has been created or not. See, I got a JSON file. So I'm opening it with the Visual
Yes.
Studio Code editor. See, this is the JSON. Yeah. So it is showing in detailed way, right? The coordinates also it is showing the coordinates in the PCB, like editor, okay, layout designer. So the positioning. So at this particular coordinate, so yeah. So this is the description of the error. Okay. So pad to ground of C3 on front copper. So now see, just perform this DRC verification on your own with the help of, not with the help of the graphical option, okay, which is found in the KiCAD user interface, graphical user interface. Just try to use the command line interface and try to perform the DRC verification with the help of command line interface. And now for each and every error, try to resolve it on yourself, troubleshoot on yourself why that error is occurring. So just if you found any error, just search for this particular error. Okay, you can use AI also. It will tell you what are the reasons for occurrence of this particular error and how you can resolve it on yourself. First you try to resolve it on yourself. If in case you are unable to resolve, then let me know what are the errors you are able to resolve and what errors are you are unable to resolve. So again, I will take a session for what kind of errors you are unable to resolve. I will take a separate session and I will, let's together we can troubleshoot, or else I can take control of your system with that any disk, and then I will try to sort out the errors. Okay, so these are like, there are so many commands. I'm not explaining each and every command in detail because it will deviate from our primary thing. Okay, so again I just want to an interlinked concept, so that's why I'm explaining one more command. So earlier we discussed this export schematic into PDF, right? So KiCAD -CLI SCH export into PDF file format. So to the same command I just want to add one more attribute. Okay, so attributes will be having this double dashes prefix. Okay, so if you see, you want to export the schematic into a PDF, but you just want to only certain layers to be plotted in the PDF, not all the layers. See, in PCB we are having so many layers, right? We are having front copper, back copper, front silk screen, back silk screen, edge cuts. So like so many layers are there, right? For example, you want to plot only front copper and back copper layer. So why we export only specific layers into PDF? This will help us to troubleshoot certain things in a easy way. So for example, you want to have a separate PDF for copper layer. It could be front copper or back copper. Separate PDF for copper layer, for edge cuts layer. So yeah, then you can use this particular attribute. So attribute name is layers. Okay. So after passing layers, you need to specify comma separated list. So the layers must be comma separated. So for example, front dot copper comma back dot copper. You can also specify edge cuts layer also. Okay, for example, I'm just taking front copper and back copper layer. Now I'm just hitting enter option. I think input file is missing. Let me check. Export to PDF, correct. Layers are also correct. File is also there, but still it is showing. Let me pass the attribute over here. Hyphen layers front dot copper comma back dot copper.
F dot.
F dot. Is there
Check
any
your
mistake?
command, sir. There's a
Oh,
mistake.
okay, okay. Front dot copper comma back dot copper. Layers. Now, I think everything is fine. Let me just. Okay, here actually it's not a schematic file actually. It's PCB. PCB export PDF, and here layers are front copper and back copper. Here also you need to see these layers exist for PCB file, not for a schematic file. Now let's check. Yeah, plotted to epaper -esp32.pdf. Now let's check. Uh, See, now in the PDF you can find only front copper and back copper layers. Now we have exported the PCB into PDF. See, this is the front. You can find both front copper and back copper. See the blue color one and red one. So now you want to export all the layers. Directly pass. There is no need to specify the layers then. Explicitly, no need to specify the layers. Directly pass. As far as I know, layers is an optional parameter, I think. Let's check. So KiCAD -CLI PCB export PDF, and we have passed the input file. Let's hit enter and let's check. Okay, at least one layer must be specified. So layers is an required parameter.
Maybe layer star.
Yeah. Now what we'll do is, so that's why there is one more flag also. Okay. So I just want to reconstruct this particular error. So that's why I just told you. So from this, what we can understand is like, so the assumption of uh, uh, not specifying any layer explicitly, it doesn't necessarily mean that it will be plotting all the layers, because layer is an required parameter. You cannot if you do not pass the required parameter, it will definitely throw an error asking you to specify at least one parameter. So in such a case, see, if you want to specify all the layers, it will become a huge command, right? Because front copper, back copper, edge cuts, silk screen, so many layers are there. So that's why there is one more flag also. So that is all hyphen layers. Okay, all hyphen layers. So this is a flag. Now hit enter. I think it is showing some error again. Input file KiCAD hyphen CLI PCB export PDF.
Sincerely, it's clear to me, so I can do more research on that, sir.
Okay. So now we will jump into KiKit. So yeah, actually I just verified the thing. So this all layers flag actually doesn't exist in KiCAD. Okay, we need to explicitly mention only. So as I can check, there is no shortcut. Okay, you need to specify all the layers. Hyphen hyphen. Okay, wait a second. Yeah, hyphen layers. We need to specify all the layers. So we'll specify, we'll export this PCB uh, into PDF, and then we'll jump into KiKit automation. Okay, how to install KiKit, how to set up, we'll discuss about that. Yeah, front dot copper, comma back dot copper layer, and then we'll be having paste layers also, front paste, and then we'll be also having front dot. See, while specifying silk screen layer, S should be capital for silk screen. Okay, if it is in lowercase, it will return an error. Again, back dot silk S. The ending S should be capital, which indicates a screen. Okay, front dot mask and bottom mask layer. And apart from this, there would be something like courtyard layers also. We will discuss about these courtyard layers as well. We are having so many applications on that also. Front dot courtyard and back dot courtyard. Yeah, so here comes the main layers. Edge dot cuts, which describe the dimensions of your PCB. So there are some additional layers also, we can omit them. Like for example, if you take
Mistake. Edge cut.
edge cuts, yeah,
Edge
thanks for
dot.
identifying. Edge dot cuts. So apart from this, we will be having some other layers also, like drawings dot user. These are actually some additional layers. Okay, drawings dot user, and comments are also there. Comments can also be exported into PDF from the PCB. A PCB can also have comments. Let's just verify the command. KiCAD hyphen CLI PCB export PDF hyphen hyphen layers, where all layers must be comma separated. Front copper, back copper, front paste, front silk screen, bottom silk screen, front mask, bottom mask, front courtyard, bottom courtyard, edge dot cuts, drawings dot user, comment. I'm hitting enter. Comment is missing. Okay. Think. Okay, apart from comment, I think rest all layers must be plotted in the PDF. Let's just check. See, this is the PDF version of your PCB. I think last time when we performed DRC, we got 57 or some errors, right? Next time, just try to work on them. Okay, try to troubleshoot on yourself. If you are unable, just let me know which specific DRs you are unable to troubleshoot. I will help you in that. I will take control of your system and we will together solve that those DRCs. Let's make that PCB 0 DRC. Okay, DRC error, no violations, DRC violations. Yeah. So now let's come into the next concept, how to install this KiKit. Okay, so already we discussed in the main KiCAD home screen plugins. You need to go to these plugins, right? Plugin and content manager. So there one pop-up will appear, a dialog. There you need to type for KiKit and you can click on install option, and I already told you to click on apply changes. So apart from that, there is another step also, okay, that you need to perform. So I have already did it on my system, so I'm just not repeating the same thing because it will take a little bit of time for installation. See, you need to pass this particular command, pip space install space KiKit. Okay, this is the command for installation of the KiKit on your system. Pip space install space KiKit. So once you just pass this command, so all these will get execute. So yeah, so to verify if this KiKit has already been installed, successfully installed on your system or not, just pass KiKit hyphen hyphen help. Okay, KiKit space hyphen hyphen help. When you just pass this particular command, if you get something like this, okay, usage, KiKit options, commands, arguments, if you get something like this response, it indicates that the installation of KiKit is successful. Okay, what is the command that you need to pass? Pip space install space KiKit.
Okay.
Yeah, KiKit or KiKit. See, already it is there on my system, so that's why it was executed so fastly, or else it will take some time because you need to install some dependency files over here, as you can check. They are actually, they occupy very small space, not a huge library. So yeah, so what is the one more observation, how to reconfirm whether the KiKit installation is successful or not? For that, open the PCB. Okay, open your PCB or else PCB editor. Okay, you can open the PCB editor. So in the PCB editor, here you can find two options. Okay, so one is KiKit and another, see, one is KiKit show or hide references and another one is KiKit to panelize PCB. This option will appear only when you are done with the entire setup. Okay, what is the first thing? In the plugins and content manager, just search for KiKit and click on install option, and then go navigate to command line interface, KiCAD command line interface, and pass the command pip space install space KiKit and hit enter. Wait for the installation to be completed, and just to for a reconfirmation, pass the command KiKit space hyphen hyphen help. Just check if KiKit is responding, and then come to this PCB editor and just check if these two options are being reflected or not. Okay, if these two options are being displayed, then it is an indication that KiKit has been successfully installed on your device. Now what I'll be doing is, like, I'm just clicking on panelize PCB. Click on S. So uh, click on panelize PCB, and then this particular pop-up will appear. Okay, here you need to select two different files. Okay, two files. First one is the input file for which you are trying to generate. See, I have already panelized your PCB earlier. So now what I'll be doing is I'm selecting the original PCB. Okay, the original PCB board, the same board that for which I want to generate, for which I want to do the panelization. And the next one is the output file. Here you can give some name, for example, panel out. Okay, see, I will explain all these options in detail. Okay, there are so many options like layout, how to configure these things, H space, V space. Okay, how to configure all these things, and then uh, yeah, so many options are there. We will discuss about all these options like source. Okay, type. Again, in type we are having rectangle annotation. So what is this source type? Stack, tabs, this spacing, all these options we will discuss in detail later. Okay, cuts, we are having different options, for example V cuts. Like this, so many options are there. Framing, tooling, fiducials. So yeah, so like this, so many options are there. Okay, I'm just clicking on panelize option. Or else you can do one thing, you can copy this particular command from here. Okay, go to the command line interface. You can also run the same command from the command line interface also. I'm hitting enter. So now this will perform the panelization. Okay, let me just check if new file has been created or not. So for this I need to go to the, I think we have named it as panel out, right? Yeah, I think, yeah. Now let's try to open this panel out in KiCAD. Okay, but as you can see, it is showing the only one PCB. Is it right? So what do you think the reason could be why it is showing only one PCB? Any idea? Hello. Hello. Can you hear me? తినలే ప్రభు. నెట్ అయిపోయిందా బ్రో? నాకు రావట్లే.